Okay, in the last question, steady state creep rate data for nickel at 1000 degrees Celsius is given. The activation energy for the material is given, and steady state creep rate at 850 degrees Celsius and 25 megapascals is asked. So we first need to write the relation between steady state creep rate and the stress level and the activation energy and temperature. So this type of relations, where an exponential term is included in the expression, is known as Arrhenius relations. This is the stress level. This K and N are material specific parameters. They need to be determined. The activation energy is given to us, and R is universal gas constant, 8.314 joules per mole Kelvin. So we have 10 to the power minus 4 strain steady state creep rate for 15 megapascals and 10 to the power minus 6 creep rate for 4.5 megapascals. So let's say that for a ratio like this, we have K sigma 1 to the power n exponential minus Q over RT1, then K times sigma 2 to the power n exponential minus Q over RT2. Okay, so these terms will cancel out, these will cancel out, and then we will have epsilon s1 dot over epsilon s2 dot is equal to sigma 1 over sigma 2 to the power n. We know the numerical values from the table given to us. So we need to take the logarithm of both sides. So log 10 to the power minus 4 divided by 10 to the power minus 6 times is equal to n times logarithm of 15 divided by 4.5. If you divide this term by this term, you will get n, and that turns out to be 3.865. This is our n value in this expression here. Now we need to determine K, so take one of the data points. So let's take the first one. So 15 to the power 3.865 times exponential minus 272,000 joules per mole divided by 8.314 joules per mole Kelvin, and times the temperature of that point, which is 1000 degrees Celsius or 1273 kelvins. So this whole thing is in the exponential term. So all we need to determine is the value K. And we know this to be 10 to the power minus 4. If you do the calculation, this turns out to be 412.77. Then, at a temperature of 850 degrees Celsius, stress level of 25 megapascals, we know K, we know N, then we can calculate the strain rate at that stress level. (412.77 times 25 to the power 3.865 times exponential minus 272,000 divided by 8.314 times 850 degrees Celsius is 1123 kelvins. If you calculate this, you will get a steady state creep rate of 2.326 times 10 to the power minus 5.